So it's my chapter 3 exam for my physics class. I had to do question 8. So for the first part, 8A, it says, a cyclist going around a circular track at 10 meters per second has a centripetal acceleration of 5 meters per second squared. What is the radius of the curve? So the centripetal acceleration of the cyclist is given, which is 5 meters per second squared. The velocity is 10 meters per second. So you have to calculate the radius. And then for centripetal acceleration, it's A equals V squared over R. And then plug in the numbers. So you would plug in 5 equals 10 squared over R. And then 10 squared is 100. So then you would get, and then you would do, once you get 100, you get 5 equals 100 over R, and then you could just multiply the R, bring it to that side, and divide the 5 and bring it over here. So then you have R equals 100 over 5, which equals 20 meters. And then for part B, it says, a race car is moving at 40 meters per second around a circular racetrack of radius 265 meters. Calculate the period of motion. So the given velocity is 40 meters per second, and I have to find the period of motion t, which is v equals s over t. And the distance traveled is 2 pi r, so then I would rewrite v equals 2 pi r over t, and then solve for t would be 2 pi r over v equals t, and then I could just do 2 pi r over v equals t. Then I plug the numbers in. Then I would do 2 times 3.14 times 265, which equals 164.2. And then I would divide that by 40. And then I get 41.6 seconds. And then for 8C, so you can see that better. For 8C, it says calculate the car's centripetal acceleration. So centripetal acceleration is AC equals V squared over R, which equals 40 squared divided by 265. Then you get, and that equals 1600 over 265, and then you divide them, and what you get 6.04 meters per second squared. And then 8AD says the wheel of a stationary exercise bicycle at your gym makes one rotation in 0.67 seconds. Consider 2 points on this wheel. Point P is 10 centimeters from the rotation axis, and point Q is 20 centimeters from the rotation axis. Find the speed of point P on the spinning wheel. So the angular speed of the wheel is omega equals theta over t, and then one rotation is 2 pi r. So I would plug in, so theta equals 2 pi, not 2 pi r, equals 2 pi. And then omega equals 2 pi over 0.670, which equals 9.38 rads over seconds. And then the equation close to angular speed would be velocity equals omega r. So then I would plug in, so I'm gonna just write it down, velocity equals omega r, and then I would plug in v equals 9.38 times 0.1, which equals 0.938 meters per second. And then for 8E, it says find the speed of point Q on the spinning wheel. So then I would just do the same thing. So it'd be V equals 9.38 times 0.2. Then you would get 1.876, but you can round that to 1.88 meters per second. And then for 8F, it says find the centripetal acceleration of point P, and then the centripetal acceleration is A rad equals V squared over R, and that equals, and then you plug in the numbers, so you would do 0.938 over 0.1, but you have to square it because the square is there, so you gotta put it here. And then you would get 8.79 meters per second squared. And then for 8G, so you see how I did it there, and it says find the centripetal acceleration for point Q. Then I would do the same thing I just did, the V squared over R. So I would just do 1.876 over 0.2, but I can't forget to square it, to put the squared. And that equals 17.60 meters per second squared. And then for 8H, I have put, it says for points on the spinning wheel, as the distance from the X increases, do the speed and the centripetal acceleration increase or decrease? Then I have put they both increase, both the speed and centripetal increase, centripetal acceleration increase. And then for 8I, it says the planets Venus, Mars, and Earth all move in approximately circular orbits around the sun. Use the data in the table below to find the speed of each planet in its orbit. So it says enter the speeds of Venus, Earth, and Mars in kilometers per second separated. So the speed of Venus equals 2 pi r over t. So then I would plug in, I'll just plug in the numbers. So 2 pi r, I'm doing Venus first, forgot to say that. I'm gonna do Venus first. And the numbers for Venus is 1.08 times 10 to the 11th power. So 2 pi r times 1.08 times 10 to the 11th power divided by, and then the orbital period is 225. So I would do divided by 225 times 24, because 24 hours in a day, times 60 minutes, and then times 60 seconds. You would get, and then that equals 34.9 kilometers per second. I'm gonna put Venus, and then I'm gonna do Earth next. So I'm gonna just put it first. And then Earth's is 1.5 times 10 to 11th power. So I'll do the same thing again as this did, but do 2 pi times 1.50 times 10 to the 11th power over, and then Earth's orbital period is 365. So 365 times 24 times 60 times 60, and then that equals 29.9 kilometers per second. And then I'm gonna do Mars, and then Mars is 22.8 times 10th to the 11th power, and then the orbital period is 687. So I would do the same thing again. So I would do 2 pi times 2.28. Let me erase that. 2.28 times 10th to the 11th power divided by 687 times 24 times 60 times 60, and that equals 24.13 kilometers per second. So those are the speeds of all of them for Venus, Earth, and Mars. And then for 8, skip line, 8J, says use the data in the table above to find the centripetal acceleration of each planet. And then next, the centripetal acceleration is given, and that equals A equals V squared over R. So then now I'll just plug in the numbers. So I would plug in, I'm gonna do Venus first again. So for Venus, I'm gonna write it right here, equals it's 34.9, but if you like take it back, the thing is 3.49. So you do 3.49 divided by, well, 3.49 times 10th to the 4th divided by the original number, which is 1.08 times 10th to the 11th. And then you get, and that equals 11, no, not 11, that equals 11.28, but you can round it to 11.3, then you move the decimal over 1, then that you get 1.13 times 10th to the negative 2, and then I'm gonna do Earth. Earth is then I would do the same thing again, the V squared over R. Then I would do 2.988 times 10 to the 4. Because I got, it's 29.88, but I rounded it to 2.9 right here. And then I just go back, I move the decimal place 1 to 2.988. So that's what I get it here, so you don't get confused. And then you divide the number, the orbital radius, which is 1.5 times 10th to the 11th. And then you get 5.952 times 10 10th to the negative 3 meters per second squared. Let me write it for this one too. And then for Mars, do the same thing, the V squared over R. So then you would do let me fix these. I haven't put squared. So you're supposed to put 2.413 times 10 to the 4th squared over 2.28 times 10 to the 11th, which equals 2.55 times 10 to the negative 3, and then it's going to be meters per second squared. And then here's, so it just looks clearer. And then for 8K, right here at the bottom, it says, as the size of planets' orbit increases, do the speed and the centripetal acceleration increase or decrease? Then I put both the speed and the centripetal acceleration decreases. Like that, and then run out of room, so I'm gonna flip it over. For 8L, it says object A is moving at a speed of V in a circle of radius R. Object B is moving at a speed 2V in a circle of radius R over 2. What is the ratio of the period of object A to the period of object B? So the speed, for 8L, The speed of the object in circular motion is v. The formula is v equals 2 pi over t. And then the time period t equals 2 pi r over v. And then, so for object A, because they have two objects, for object A, TA equals 2 pi r over v. And then for object B, TB equals 2 pi parentheses r squared over 2v. And then next you would combine object A with object B, or divide it. So just do TA over TB, then you just plug them in. So you do 2 pi r over v over 2 pi parentheses r squared close parentheses over 2v. Then you get 1 over 1/4, and then that equals 4. And then for 8m, it says, what is the ratio of the centripetal acceleration of object A to the centripetal acceleration of object B? And then for 8m, the centripetal acceleration for object moving in a circular path is A equals V squared over R. And then, so I would just write, then I'll take this problem right here from TB, object B. Then I would do V squared over R over 2V squared over R over 2. And then you would get, after you do that, you would get 1/4 times 2, 1 over 4 times 2, which equals 1 over 8. And then it equals, then you turn it into a decimal, then you'll get 0.125.